Yo, what's up, YouTube? It's your boy Josh. Oh no, Abraham. And we're back with the introductions to general chemistry. What? Introductions to the general chemistry. No, there's no the. It's to general chemistry. Okay. I was looking up PS orbitals. Gotta write though. I got the gender studies class today. Not a big fan. I mean, it's pretty okay. I wouldn't say it's the best thing out there, but it is an important class that should be having, right? Gender studies. I used to be one of those like, oh, why do we have to care about gender stuff? But you have to care about gender, what is happening and stuff, right? I believe. I believe. So last time I just proved what the wave functions helps us to find, like probability density, radial probability. Shoo. I mean, what exactly are NLM to the wave function? Like, are they derivatives, integrals, or something like variables? They're parameters, not derivatives or variables, quantized constants. They appear when solving the Schrödinger's equation because certain mathematical conditions restrict what values the wave functions can take. Quantized parameters. Can you show me a simple example of quantized parameters, like simple equation, how it has quantized parameters, because the word is not registering in my head. I don't know what is quantized parameters. Do you know? You know this? I don't. Electron is trapped. Oh, how do you make an equation with this? Electron is trapped between two walls. If this is air inside the box, v of x, is it velocity? So the electron cannot exist outside. What this is? Schrödinger's equation inside the box. It appears because only certain standing waves fit perfectly between the walls. So in atoms, the wall are electrostatic potential of the nucleus. Okay, the same math applies. That's how it emerges as quantized constants like n, ensuring wave functions fits boundary conditions of the atom. So the quantized parameters are basically just terms use. Yeah, that's what the NML means. They are basically to show which orbital its spin, stuff like those. When you want to explain how the electron behaves. But my question was, I think it's better not to go deep, right? Okay. The quantized parameters of the I forgot the spelling. Schrödinger. Principal quantum number azimuthal quantum number, and this is magnetic spin number, right? I believe magnetic quantum number, spin number, yeah. Okay, I'll just write it. Principal quantum numbers correspond to Bohr's. Energy of the orbital increases with n, and electron strain contains orbital with the same principal quantum number. Number of nodes is n minus 1. Now, can you explain the three parameters based on how the atom like how each number helps us explain the electron position, etc. Please reset timer for 30 minutes. Each of the three quantum numbers describe a specific aspect of the electron wave function, how it behaves in space around the nucleus. Principal quantum numbers comes from the radial part of the wave function, determines how the electron, on average, from the nucleus, also fixes the energy levels. Higher the energy electron, further from nucleus, more radial nodes, regions of zero probability. Principal quantum number, angular momentum quantum number, magnetic quantum number. Nope. Principal quantum number comes from very far the wave function, determines how far the electron average from the nucleus. Comes from radial part of the wave function. Higher energy and more radial nodes, n-1 regions of zero probability to find the electron. Angular momentum quantum number. Azimuthal number comes from the solving the angular part of the wave function, determines the shape of the orbital. Comes from solving angular part of the wave function determines the shape of the orbital. Magnetic quantum number determines the azimuthal part of the magnetic. What? Determines the orientation of the orbital in 3D space, how the dumbbell or clover is aligned. Could you explain more on this? Oh, it was a wave function that was. Must be so the wave function is a single value when you rotate 360. Each ML represents a different rotation symmetry around the z-axis, effectively a different orientation of the orbital. What was that? Magnetic quantum comes from the ASI part of the wave function. Helps us determine the orientation of the orbital in 3D space. Allowed values -1, 0, +1. Yep. So L orbital 0s 1p 2d 3f. Energies and magnetic quantum number 0 1 2 3 orbitals s p d f 0. Mhm. A subshell is a group of orbitals with same values of n and l. The magnetic quantum number characterizes the energy of an electron when an external magnetic field is applied. What does this sentence mean? A subshell is a group of orbitals with same values of n and l. It means n fixes the energy level, it fixes the shape of the orbital. All orbitals that share the same n and l belong to the same subshell, even if they point in different directions. Okay. Subshell is a group of orbitals. N equals 2, L equals 1. You have two p subshells. It contains three orbitals. Okay. What does that mean? The magnetic quantum number describes how an orbital is oriented in space without a magnetic field. Without a magnetic field, all orbitals with same n and l have same energy. With an external magnetic field is applied, the orientation interact differently in the field. This causes splitting of energy levels called Z-man effect. For example, p subshell, there are three orbitals, uh, three p orbitals. Let me just. Okay, px. This splitting is direct evidence that Mi affects orbital energy only when magnetic field is percent. This causes splitting of energy levels called the Z-man effect. So when electric field is introduced, external magnetic field is introduced, uh, so the electron in an atom, is it also existing in electro form or slightly higher phi energy? However, it's not electromagnetic wave like light. Yeah. So, so from Z-man's effect, could we say that the negative charge subshell not exactly. Z-man effect doesn't directly label negative or positive orbital synergy. It depends on how the orbital's magnetic moment interacts with the external magnetic field. An electron's orbital motion produces a magnetic dipole. Electron's orbital motion produces a magnetic dipole. When you apply an external, the energy shifts according to the. So it's an alignment of the orbital's magnetic moment. It's not a fact that electrons are negatively charged. The negative charge determines the direction of the magnetic moment. Is it because it's existing in perpendicular form or something that the magnetic uh, No, shift. Shift. Exactly. Perpendicular to it. Okay. Makes sense. So could you help me? Wait, I could use YouTube, right? Yeah. Z. See equations, bro. I wanna see visualizations. Say we are I I know. So that's the one. How are the how are the other X? Hmm. So here it's PZ. Py is 0, Pz is -1. Magnetic field, suppose the magnetic field is along x-axis, so the energy shift on each orbital depends on the component of its magnetic moment along the field. Aligned with the field, energy increases. Energy decreases, energy increases. No, station on the dumbbell, as I heard the top, the each dumbbell Whoa, what? How did you go from there? What did I press that it went to the first? What did I press? Shift backspace? No. Shift left? No. Upwards? Oh, up. Okay. Ha. That's gonna come in useful. So the top and bottom has negative, positive charge or something. I heard, not head. AI is working double time. Each p orbital has two lobes on the opposite side of the nucleus. Each p orbital. The lobes. Think of the lobes as clouds with opposite sides of the wave function, sometimes loosely called positive. Uh, that are not real charge. It's a phase. Hmm. 30 minutes? Come on. My series set a timer for 15 minutes. Let me get some water. Wait. Oh. What are these? Orbitals, right? Just got an idea.
One gem gun.
Oh no, 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 no. Wasting time, wasting time. Each PR orbital has two lobes. Suppose the magnetic field is along the x-axis, parallel to px. Yeah, electron orbital motion produces a tiny magnetic moment. The interaction depends on how lobes along the axis. Lobes perpendicular. Magnetic perpendicular energy unchanged. PC lobes perpendicular to the field in other plane. Wait. X, Y, Z. Mm. So, so for this one to be unchanged, that's what it is, magnetic field that's passing through P of y would be through its node, and there is no magnetic field on its x-plane. On the plane of y. Instead, it's x. Wait, x, y, z. It's aligned to the x-axis. It's not above. So it's not going like this. It's going. How is y not included? Dude, my imagination is too small. Okay, I see it. I see it. I see it. Imagine each dumbbell spinning around the nucleus. The P of X spins so its magnetic moment is along B. No, if you start drawing sketches, this GPT is gonna have a hard time. Wait. So you y is not affected, but but I did not understand about the spin. Like, for me, visually, the px and pz even after the magnetic field is introduced, it just looks the same Yes, the shape of the orbital doesn't physically deform when magnetic field is applied. What changes is the energy associated with the orbital's orientation. Think of the dumbbell as a cloud of electron possibility. The cloud itself doesn't shrink, stretch, or rotate just because of the field. What Z-man effect does is shift the energy of the whole orbital depending on its magnetic moment, aligns with the external field, so still looks like dumbbells in space. Energy level splits. If you plotted energy, you see px go down. Pz goes up, py stays the same. The spin of the electron is separate. Mm, so another question I have is uh, these are all electron we are talking 15 minutes. Hey Siri, set a timer for 15 minutes. Hey Siri, set a timer for 15 minutes. So all three should have same charge. I forgot question mark. Z-man effect only changes the energy of the orbital depending on how its magnetic. Okay, the positive negatives are just faces. Um, Parallel, less energy. Px orbital aligned parallel to magnetic field. Its magnetic moment aligns with the field. Energy decreases. Px perpendicular to the field. The magnetic moment is perpendicular. Splits the degenerate p orbitals into three different energy levels. Depends on how each. Okay, I kinda understand this. I kinda understand it. So how do I explain Z-man effect? So for s orbital, Z-man effect is not noticeable. Exactly. Okay. Explaining Z-man effect. How orbitals act based on external mm, so right here we're using example of p orbitals. We got p of x, we got p of y, and no, that's p of z. Fucking hell. parallel to the orbital. And least energy this orbital the field passes through each nodes and blobs or so this orbital experience most energy PFZ. The magnetic field only passes through its node. Therefore, no effects. Yep. But I still don't know how we would quantify this or how we could. A lot of questions coming up. A lot of questions. Viele Fragen. I just learned this last sentence. That's it. Yeah, I mean, if I was really intelligent, I wouldn't be here, right? Yeah. So maybe it takes time for me to learn, but I just own it. I own it. Would it be equals one? DZ2. This is the last. Just filling in the last. Okay. 15 minutes? God damn it! Gotta write the orbitals, right? Let's say Z3. I need a bit more visualization. I need to see the axis. Oh yeah, there we go. That's Z, and okay, that's the opposite of this. What's this now? We're just filling in the space these two cannot take in. Okay. Now, orbitals and quantum number. The shell with principal quantum number consists of exactly n subshells. Each subshell consists of a specific number of orbitals, whereby each orbital corresponds to different value of ml. There. Okay, I gotta cook. I gotta cook something. So before I had a recent idea of making a separate video on explaining a topic, right? So what if I try to explain Z-man effect? How do I explain? Yep. YouTube, I'm gonna end the stream. I gotta head to class. I gotta cook something. Peace out. I really appreciate you, Bon. Really appreciate you for being here. But like we said, I this page that was, I think maybe 3 pages. That's it. All I looked up. I gotta fasten this. We gotta get to periodic table today. Today. Peace out, YouTube.